Welcome back, everybody. Today we're talking about something called CPCTC. That stands for the corresponding parts of congruent triangles are congruent. Let's break that down a little bit. We have two triangles right now that we can see are clearly congruent. We see that the side lengths match each other, okay, and the angle degrees look like they're pretty much the exact same. Okay. The corresponding parts are the sides that match on the two triangles. Here we see that side AB and DE have the same length, so they would be considered the corresponding parts. BC and EF are corresponding, as well as AC and DF. And we also have the same thing going on with the angles. We notice that angle A and angle D are congruent, angle B and angle E are congruent, as well as C and F. So we're going to look at a valid statement in a second having to do exactly with which pieces are corresponding with which. But let's look at the rest of this definition. We talk about congruent triangles. These two triangles are congruent, which means now that the corresponding parts of these congruent triangles are congruent. The parts themselves are congruent. That means angle A and angle D have the same measure. Angle B and angle E have the same measure. And angle C and angle F. Then we look at the sides. Corresponding of A, B with DE, correspondence with BC and EF, and correspondence with AC and DF make those sides all congruent. Okay? Now, the valid statement, as we said before, has to do with the corresponding parts themselves. So here's how we're going to write these. We're going to write out one of the triangles. Okay? Generally, you write them out in alphabetical order. So we're going to write this one out as ABC. And we're going to make sure that we say that it's congruent to whatever the other triangle happens to be. But we want to make sure that we list it in what's called a valid statement, which means that whatever angles correspond, they should be listed in the proper order with each other. So if angle A and angle D are corresponding, we want to make sure that we list angle D first. Then we move up to angle B. So I would want to follow along with my other triangle to the next angle that matches along with the side. I went AB to DE. So angle E. And lastly, angle C matches with angle F. So I want to make sure that it is in the third position as well. We can also see with the valid statement that not only do the angles match up, but the sides themselves. AB and DE are corresponding. BC and EF are also corresponding. And lastly, AC matches with DF. Okay, so everything corresponds angle-wise and sides. Okay, that's going to be useful for when we start solving problems, because we don't necessarily have our triangles always drawn in the same orientation or looking like they're facing the same direction. So we can actually use the valid statement to do a lot of our math for us. Here's what I'm talking about. This problem says that if triangle ABC is congruent to triangle MNO, solve for X and Y. Now this valid statement is actually super useful here because we're looking for maybe an angle. And I know the angle O and angle C correspond, so they're congruent. So if I figure out what the value of angle C is, I automatically get angle Y. How am I going to get angle C? Well, I should start thinking about the interior sum theorem. 85 plus 45 plus y is going to equal 180 degrees. Let's add these like terms together. That gives us 130 plus y equals 180. We're going to subtract the 130 from both sides. We're going to end up with y equaling 50 degrees. So that took care of our angle. Now, let's look at the value of x. Well, x is on one of the sides. It's on side MN. Well, thanks to our valid statement, if I look for the same corresponding side on the valid statement, which would be AB, I know that I have to look for the length of AB, which happens to be 15 here. And because these two are corresponding, they're congruent, which means that I can take 3x and make it equal to 15 and solve. Divide by 3 on both sides, that gives me x at the value of 5. We did that purely based off of that valid statement. So, I have another problem for you. This one's a little bit different setup, but it's the same idea. Okay, why don't you guys try this one on your own? Think about the valid statement, use it to your advantage, and we'll discuss it in a moment. Alright, let's see how you did. First of all, we're trying to solve for x and y. And we notice that we have triangle STU congruent to triangle RUT. Okay, well, if I look at that STU versus RUT, these triangles are kind of flipped. So I'm going to definitely want to trust my valid statement for this one. Looking for the value of x. Well, x is up here at angle RUT. So I need to think about the angle that matches on this triangle, which is angle STU. So if I can figure out what this angle is worth, I will get this angle right away. By the way, just in case you're curious how I match those angles, RU came first, so I want to go with ST first. That gave me this side. Okay. And then I looked at UT, so that would match with TU. So that's how I matched those angles. So I got to figure out what that's worth. Well, again, triangle sum theorem. 90 plus 20 plus whatever this happens to be. We'll call it A for right now. Equals 180. It's going to give 110 plus A. Subtract the 110 away. It's going to leave us with a value of 70. Now this angle right here is 70 degrees. We already established that these two are congruent. So 7x equals 70. Divide by 7 on both sides. That's going to give us a value of 10 for x. Then let's look at y. Y is located on side TR. Well, TR are the first and last positions in my valid statement. So if I look over here, I'm looking for side SU. SU, we can see, has a length of 8. That means that these two sides, which are corresponding, are congruent. So I can set this up as 2y equals 8. Quickly divide by 2. That gives me y equaling 4. How'd you do on that problem? Hopefully you got that one correct. If not, maybe take a second to rewind this one, see if you can get that one on your own. These problems are a little bit more challenging because you're depending on going back and forth between the valid statement and the picture itself until you get used to being able to visualize the triangles. Use this valid statement. It's super useful. Okay, I'll see all of you later.